Hello, and hey, ladies and gentlemen. I'm Professor Jellyfish, and welcome to another part of Realism Review of Subnautica. This is a series where I will be examining the creatures in Subnautica and try to figure out how realistic they are when compared to real-life animals. This is a series that will not only look at the design and look at the creatures, but it will also consider the biomes and environments that they are found across in the game's world. This time we will be going deep down into a dark hole and look at a large floating blob. That's right, we will be looking at the crabsquid. So this is what I would say is one of the more strange and alien-looking creatures in Subnautica. It also has a very informative name, as it looks very much like the result of a crab and a squid getting a bit too familiar with one another's reproduction methods. Though it would seem that Mom's best features skipped a generation, but we are not here to discuss the lack of ink fart. The in-game databank states that it has a total of 10 limbs that are used for both swimming, walking and eating. It also states that it eats rather quickly. It is also stated that it usually hunts the bioluminescence that is produced by herbivores. The stomach is said to be inside the large upper body of the crabsquid, and it can also change the size of the transparent layer surrounding the stomach. It also has the ability to produce an electromagnetic pulse that is so strong it is able to damage electronics and presumably stun animals nearby. It is also stated to produce frequent clicking sounds as it moves through the water. As per usual, we will go through the aspects of the crabsquid's biology and try to figure out how realistic they are. First and foremost, I want to talk about the size of the crabsquid, because it is not only realistic, but it is also very fitting for the environment we usually find the crabfish in. The crabfish seems to be the result of deep-sea gigantism. This is a strange phenomenon we do not yet fully understand, but it results in a lot of invertebrate species growing much larger in the deep water when compared to their shallow water cousins. As stated previously, we do not yet understand what exactly causes this, but three general theories have been proposed. One is the lower temperature, the other is food scarcity, and the final is reduced predation pressure. While I will not elaborate much on the theories, perhaps I can figure out which is most likely to be the cause of the crabfish's size. Reduced predation might be a possibility, as there seems to be little directly that can hunt the crabfish, but there are of course larger creatures in the biome that we find the crabfish in that might be able to attack it. The fact that the crabfish have developed the means of producing an electric shockwave might even indicate that it needs protecting from things larger than itself. So, moving on to food scarcity. This does not seem to be the plausible explanation, as the in-game databank states that the crabfish often fills its stomach. This means it has a good access to food and can often eat. So, finally we'll look at the colder water temperature. This might be the most likely. The reason for this is that the temperature of the water will naturally be decreasing as we go deeper into the water. The general idea behind this theory is that the increasing size is a result of decreasing temperature, as it will result in larger cells for the animal and thus a longer lifespan. Both of which seems to be combined and fits especially well for the crabfish, as this is especially prevalent as crustaceans here on Earth. A good example is the Japanese spider crab, which has legs so long it can climb over cars. Not sure how many times it would need to do that, however. So, the size of this swimming water balloon might be realistic, but what about its other features? Specifically, what about its 4 eyes? We discussed this in a previous episode, that the existence of multiple sets of eyes might occur on an alien planet's vertebrates. But it does actually occur on our own planet with arthropods especially. In fact, there's one group that is famous for the amount of eyes it has. And that group are the spiders. Now of course, all of these eyes are not the same size and do certainly not film the same function. But it shows that there is a greater precedent for animals with multiple sets of eyes developing in groups that aren't vertebrate. Or in layman's terms, spineless animals need more eyes to make sure no one sneaks up on them. The size of the crabfish's eyes is also of interesting note. they are rather large relative to its body size, meaning that it is probably a predator that uses sight as one of its main means of hunting and sensing its environment. This is something that can be observed with animals that exist within something called the Twilight Zone. The Twilight Zone is an anthology-based TV series produced in America. Sorry about that, my editor's an idiot. The Twilight Zone is the second light layer of the water column that starts at about 200 meters and is sometimes referred to as the dysphotic zone. At this depth, photosynthesis is not possible, but there is some small amount of light available. As a result, a lot of animals that exist in this zone have developed large and sensitive eyes in order to gather up what little light they can in order to see predators and prey. A good example would be the hatchetfish. Now, as you can see, it has developed eyes that are much larger in relation to its body size when compared to most shallow water living fishes. The reason for these large eyes is, like previously stated, to spot prey and predators. So with this evidence in mind, it is not unbelievable for the crabfish to have developed similar means of hunting. It is also supported by the crabfish being attracted to lights. But what is a little bit more interesting is what the crabfish appears to be using, which is some kind of sonar. Now, sonar you might think was invented by humans, but we humans did not in fact invent it. We stole the idea from whales and claimed a patent before they could. Whales use it as a means of communicating with different individuals of their species and to potentially find prey items. The existence of whales and their usage of sonar means that there are animals that use sound in order to get a better idea of the surroundings. What is different though is how these sonars might have developed and how they might have impacted how the sound is being produced by the different species. Whales evolved from mammals that of course used to live on land. This is why whales still breathe air, but this is also why the sonar has become such a common trait among this group of species. See, whales produce the sound that they use for their sonar using the airways that remain since they lived on land. This is rather different from an animal that doesn't appear to have evolved from any animal that might have been living on land. I say this because a crabfish doesn't seem to be breathing air in any way. Thus I will assume that this is a species that never breaches the surface during its natural life cycle. So does this mean it is unrealistic for the crabfish to be making such noises that it might be using as a sonar? Not quite. See, there's a rather recent research by Professor Steve Simpson discovered that cods, no not that one, actually use sound to be able to communicate with each other, and they have in fact developed regional accents depending on where they're found. While this is an incredibly interesting find, we need to get back to the crabfish. So what does it mean for the crabfish? Well, it means that animals that haven't previously in their evolutionary tree breathed air are able to make sounds that they use for either communication or scanning their surroundings. With this in mind, we can safely say that it is realistic for the crabfish to have developed this ability to use sound. The question then becomes, does the crabfish have a believable utility for the usage of sound? For this, we need to consider the environment that it is found in. So, let's go down there. As we can see, the crabfish likes to live in biomes such as cave and crevices in the rock. This would mean that it is constantly surrounded by hard rock and substrate that it risks swimming into, thus damaging its translucent soft upper body. So the crabfish might be using the clicking noises it makes like a sonar, scanning the environment and keeping a constant 360-degree field of view of everything surrounding it. For a creature that can swim around and lives in these kinds of environments, this is a rather believable and practical application for the crabfish's sonar. The sonar could also be used as a means of detecting prey from a distance or if it is out of view. It could then use its large eyes in order to hone in on its target before finally striking. But while we are talking about the crabfish's swimming around, let's move on to talking about how it swims and its mobility. The transparent bladder on the back of the crabfish's body is set to deflate and inflate in order to regulate buoyancy. As discussed in the bladderfish episode, the forms known as osmosis might be what the crabfish is using. To elaborate, the process known as osmosis is when water or particles is displaced from a membrane in order to create an even concentration across a volume. An everyday example of this would be tea in a tea bag. When you put the tea bag into water, the contents of the tea bag will be gradually pushed outwards into the surrounding water by osmosis. The crabfish might be using osmosis in order to create fresh water inside its bladder. Now, why would it be needing fresh water to begin with? If you have seen the bladderfish episode, you might probably already know, but I will explain for those who do not. The reason for this is that fresh water is lighter than salt water because it has less particles in it. So when the crabfish fills its bladder with fresh water, it will become more and more buoyant and start to float upwards. Now this is of course assuming that the crabfish uses fresh water to begin with. It might be using something even lighter than fresh water, namely gas. Now keep in mind, this will repeat some points from the bladderfish episode, but it bears explaining. A lot of bonefishes have a swim bladder that is filled with gas that is used in order to maintain buoyancy and reduce the amount of energy that the fish have to expend in order to stay afloat in the water. The crabfish might be able to use a similar method with its transparent upper body. This might also explain how the crabfish is able to make the sounds that it makes. The gas inside would make it easier to produce a sound that has a wider spread across its surroundings. However, it would also make the crabfish more vulnerable to injuries in its bladder. There is, after all, a reason why most swim bladders are internal in most bonefishes. So it might be more likely that the bladder is filled with fresh water, as it would make it slightly more durable to injuries and possible attacks from predators. And speaking of predators, let's move on to the fact that the crabfish is able to make a lightning pulse from its body. Now, some of you might already know what other creatures are already able to do this. Heck, you might know of two of them. Two I am referring to specifically is electric eel and the electric ray. Now, both of these are able to produce electricity strong enough to stun animals larger than themselves. So the crabfish being able to produce electricity is believable, but like the previously asked questions, is it useful? Well, considering how vulnerable the crabfish is with its exposed bladder and otherwise exposed organs, this would act as a good means of defense from predators and as a means of catching prey. Though it is not a perfect design, as it would take a lot of energy for the crabfish being able to produce lightning strong enough to stun animals. Note that this does not mean unrealistic, nor is this a point of criticism. I am mentioning this because in a lot of animals, if not all animals in the animal kingdom, have flawed designs. Some of them have features, limbs, or sometimes use strategies that are not wholly effective. The reason why most animals have developed such strong and effective strategies is the fierce competition that occurs between all animals. But the competition does not necessarily result in the perfect designs. Rather, it results in the most effective designs outcompeting the others. It's like the free market, except way more hardcore. Now onto the environment we find the crabfish in. This is somewhat realistic and believable. The problem with it is that the biomes such as caves, deep crevices should not be able to support animals of such size. But a more elaborate explanation of that is coming in a future episode. As for the coloration, I would consider this realistic. The crabfish seems to have a minimal to no pigment on the soft part of its body, which would help with camouflage. The coloration of the exoskeleton, though, is something I have an issue with. This may sound a little bit strange, but when an animal wants to camouflage themselves in the deep sea, they actually develop red pigmentation. To understand why, we need to look at this graph. As we can see, red is one of the first colors that gets absorbed by the water. This means that a lot of animals that live in the ocean can't see red. This means if you want to stay hidden in the deeper parts of the ocean, you wear red. But now I hear you ask, why don't you just develop black pigment? And the reason for this is rather simple. it takes more energy to produce black pigment than red pigment. This means that more energy has to be expended in order to produce the black pigment, whereas the red pigment will produce the same effect. So to summarize, the crabfish, despite how alien and strange it looks, may actually be rather realistic apart from the coloration of its exoskeleton. That's all I had for you today. If you liked this video, be sure to like, comment and subscribe. And I'll see you all next time. Goodbye.